Today we'll be talking about the product rule, and the product rule of a function. When we say we have a function y of x, and this function, when we say the function has two functions multiplying it, so when we have a function y of x and the function is equal to, let's call it a u of x multiplying, so this is multiplying a v of x, meaning that we're having two functions multiplying each other and each of them have the function with respect to what, x. So what do I mean by that? I can give an example where we have our y is equal to, let's say we have here as 6x multiplying. Now when we say u and v, it means that the functions are actually different. So if u is like, let me say 6x, then our v will be something of this nature. Let's say multiplying, I have here as x plus 2. So these are two functions where I can say my u is equal to what, 6x, and my v is equal to what, x plus 2. Now the product rule helps us to simplify two functions multiplying each other. Now how do we find the product rule? The product rule for differentiation, so it means that when I take the derivative of y, that's dy dx, I will have it as equal to what? As this is the formula, it is v du dx plus u dv dx. So this is the formula we use in finding the derivative of a function when it is having a product. Now I would like to take an example to show you how to solve this. First of all, let us treat this example we have here. So if we have y is equal to 6x bracket x plus 2, I'm just repeating what I've written, then let's first solve this without using this formula. Let's first solve this without using this formula. Now I can open this bracket and I have it as what? 6x squared plus what? 12x. So if I take the y dx, I will have my answer as what? 2 comes down to the base, and 2 multiplies 6, we have it as 12x, because we subtract 1 from here, then plus what? Taking 1 down here and subtracting it, here will be 0, so x entirely turns to 1, and here is just what? 12. So our answer is 12x plus 12, and I can also simplify this by factorizing 12 out to be 12 bracket x plus 1. Now this is just the normal way of solving when you open the brackets, but most times they will give you questions that are very hard to expand. Therefore you need to use a rule to solve it, and that's why we have the product rule. So let me apply the product rule in solving this same question again and see if we arrive at this answer. So we have here we have for our y, it is still 6x plus this, so we know that our u is 6x and our v is what, x plus 2. So the first thing we have to do is to first find the du dx. So we have to find du dx. So for du dx, our answer is what? We have it as 6. Then for dv dx, our answer is what? Our answer is 1. Our answer is 1. Because when we simplify this, we have what? 6, and we do this, we have 1. So remember our formula. Our formula tells us what? That dy dx for product rule will give us what? V du dx plus u dv dx. Therefore, bringing it into this, substituting our values, we have that our v is what? X plus 2. So we have x plus 2 multiplying our du dx, which is 6. Then plus we have u, which is what? 6x multiplying dv dx, which is what? 1. So we have this as what? Opening this bracket, we have 6x plus 12 plus what? 6x. And when we add them up, we have 6x plus 6s will give us what? 12x plus what? 12. And notice this, we now have this at the same part, so we can finally factorize it to get our answer as this. So this is the formula for finding our product rule. Now let's take more questions, more examples again to solve. So what if we have a question like this? Let me look at my book. We have y is equal to then we're given y is equal to x root x. So in this place, what will our u be? Our u will be what? X, the first one. And what will our v be? Our v will be what? Root x. Remember, I can write root x as what? X raised to the power of 1 over 2, right? Then the next thing we have to find is our what? Du. So our du will be what? Our du in respect to x will be what? 1. And our dv in respect to x will be what? 1 over 2 x raised to the power what? Minus 1 over 2. I believe we know how to do this. It is still the same formula I told you, that when you find your dy dx, it will be n ax n minus 1. So that's what we just did here. For our ax raised to the power n, we did n come over this way and then subtracted the minus 1 from here. Therefore, when we're done with this, we can now bring it into our formula. Our formula tells us that dy dx is equal to what? Is equal to the v du dx plus the u dv dx. Therefore, what's our v? Our v is what? X raised to the power 1 over 2. I can just use as root x. Then our du dx will give us 1, because we multiply that to get 1, plus u is what? X, and our dv dx will give us what? 1 over 2 x raised to the power minus 1 over 2. Now let's solve this. So I can proceed to find here as what? When root x multiplies 1, we still have root x, plus here, what happens here? I can transform this x to the power 1 over 2 as what? For 1 over 2 x to the power minus 1 over 2, I can transform this to become what? 1 over 2 multiplying 1 over what? Root x, because I know that it will be having 1 over x to the power 1 over 2, and 1 x to the power 1 over 2 still gives us what? Root x. So this is entirely equal to what? 1 over 2 root x. So therefore I know that here will be x bracket what? 1 over 2 root x. So my answer can end in what? Root x plus x over 2 root x. So I can stop here, but if I want, I can find the LCM, which is good, you do that. So you can find the LCM. So finding the LCM of the both of them, I know that the LCM will be 2 root x. So therefore I have here as 2 root x as the LCM. So 2 root x, if here is over 1 as a denominator, 2 root x divided by 1 is 2 root x. 2 root x multiplying root x, we'll be having it as what? We'll be having it as 2 root x multiplying root x. Let's just leave it first like this, then we'll open it later on. And here will still remain as x. So when we come down here, we know that when 2 root x multiplies with x, is x cancelling x, right? So it will be what? 2 multiplying x, or just say 2x. Because the square root will multiply the square root and it cancels out. Then we have plus x over 2 root x. So when I add this up, what do I have? I have it as what? 3x over 2 root x. And this is the final answer. So if I want also, I can rationalize this 2 root x to go out so that I will not have a root x in my denominator. Now that is another way again of solving, because many times it is not mathematical most times, not all the time, but not mathematical most times, to leave your denominator as a sword. Or we know swords are called radicals, so, or to leave it as a sword or as a root sign. So many times it's good you take it off away from being a sword. Remember how to do that? How do we take off a sword? How do we take off a denominator which is a sword? So if we have 3x over 2 root x, how do you take it away? Is by multiplying the value of that sword up and down. So I will just multiply here by root x, multiply here by root x, and it's done. So I know that when I do that, I will have here as what? Root x multiplying with x will cancel out the root sign, and I have only just my x. So I have only here as what? 2x, and then to be what? 3x root x. So that's how we get it. Then I know that x can cancel out x here, and my final answer gives me what? Just 3 root x over what? 2, and that's the answer. So whether I leave it as 3x over 2 root x or I leave it as 3 root x over 2, the answers are correct. Now let's take one more question. Let me take my board over to the other way. Let's take one more question. If we're given this as a value of our y is equal to root x brackets 2x plus 1 raised to the power of 3. Let's solve this. Now, it will be futile for you to say let you expand this. It will work, but it will be a long work. So, but what can we do here? Now, notice something. If our u is equal to root x, which is okay, our v is equal to what? 2x plus 1 raised to the power of 3. Then our du is what? Remember, we've done for this because if here is written as x power 1 over 2, our du will be what? 1 over 2 x is power what? Minus 1 over 2, which can be written as what? 1 over 2 with x, right? We've done that already. But for our dv, let me use a different color for that one. For our dv, notice this is going to give us a chain rule, right? Remember, we've done chain rule or function of function rule. This is a function of function because it is having raised to the power of 3. So what do we do here? We find a derivative of this, just like how we did our function of function rule. So these are cases whereby we have a derivative inside using different rules. So we've used the product rule. We are working with the product rule, but inside the product rule, we saw that we also need to apply what? The function of function rule for a particular case. So you will see cases like this that will come up very well in your solvings where you have to apply more than one rule to solve a particular question. So for our dv, we have it as we now need to also break this down. So let's break this dv now. Let's break it down. Let's call, so I would like to take off here. Let's call our let's call this one u1. Our u1 should be what? 2x plus 1. And let's call our v1 to be u1 raised to the power of what? 3. Now this is applying my function of function rule. Therefore, I know that my dv will be what? My dv will be the differentiation of this one multiplying the differentiation of this one, right? Remember our formula for chain rule. So it will be the differentiation of this one multiplying the differentiation of this one. So when I differentiate this one, what do I have? When I differentiate my v1, I have it as what? 3u raised to the power of what? 2. 3u1 raised to the power of 2. And then when I differentiate my u1, I have it as what? 2. Differentiation of u1 is 2. So therefore, my dv will be giving me what? What is my u1? My u1 is 3. Sorry, 3 times 2 is 6 actually. So let me do this one. 3 times 2 will be giving me what? 6. So 6 multiplying what? My u1 raised to the power of 2. That is 2x plus 1 raised to the power of 2. So this is my dv. 6 bracket 2x plus 1 raised to the power of 2. Now, what's the next thing I'm to do? The next thing I'm to do is to bring in my formula for finding my product rule, which is dy dx is equal to v du dx plus u dv dx. Now, my v is what? 2x plus 1 raised to the power of what? 3. Multiply my du dx. What's my du dx? Is 1, this is it here, 1 over 2 sort x. So I have it as what? Multiplying 1 over 2 root x. Plus my u is what? Root x, right? Root x multiplying what? So let me put that in a bracket rather than using an x. Multiplying my dv. My dv is what? 6 bracket 2x plus 1 raised to the power of 2. So 6 brackets 2x. So let's put this one in a square bracket 2x plus 1 raised to the power of 2. Close it. Now what I need to do now is just to simplify my working. So simplify my working, I have 2x plus 1 raised to the power of 3 over what? 2 root x plus here is going to give me 6 root x bracket what? 2x plus 1 raised to the power of 2. So I can stop here, but if need be, I might need to open up my working and solve more. But I think it is good if we stop here. Or if I want, I can find an LCM for all of them. So I can find an LCM, which is going to give me 2 root x. And then I can say here's what? 2x plus 1 raised to the power of 3 plus when 2 root x divides 1, we have 2 root x multiplying this, we have it as what? 12, because 2 times 6 will give us 12. With x times with x will give us what? X. And we have this as x. So 2x plus 1 raised to the power of 2. And this is my final answer. So I can end it here. And I can also factorize this. Notice something, this can be factorized. Since here is 2x plus 1 and here is 2x plus 1. So I can factorize it by bringing out what? Just 2x plus 1. So I can say I can bring out 2x plus 1. What's the highest common factor between this and this? It is 2x plus 1 raised to the power of 2. So raised to the power of 2 plus, so raised to the power of 2, and then I can bring out my brackets. So here is then 2x plus 1, and we have here as what? 2x plus 1, we have here as, put it in a smaller bracket, plus 12x. So that when I open this bracket, I still have everything in order. So here's this, here's 2 root x. And notice something, since I have 2x plus 1 raised to the power of 2, opening this, I can also do what? I can also work with this particular solving. So working with this particular solving, what do I have? I have that 2x plus 1 plus 12x. 2x can add up with 12x. So I have this as what? 14x plus 1, and then bracket what? 2x plus 1 squared all over 2 square root of x. And this is my final answer. So I can end it here, unless if there's any need for me to expand this bracket and work with it. So I can end it here, and let's take one more question before we call it a day. So taking one more question, I would like to go down, and then let me draw a line. So we have this in our book. We have for y is equal to x squared brackets x squared minus 2x raised to the power of 4. So solving this one, our u again, let me use a different color for that. My u is equal to x raised to the power 2. My v is equal to what? X squared minus 2x all raised to the power of what? 4. So what is my du? My du is equal to 2x. And then what is my dv? Notice that for my dv, I'm going to use my chain rule again. But now I know that you understand how to do the chain rule, so I differentiate the one inside. The one inside will give me what? Differentiating the one inside, I'll have 2x minus 2. And then I differentiate also the one just outside. So this is like saying u raised to the power of 4. And that'll give me what? 4 multiplying my u. So let's call it 4u. So let me put this in a bracket. 4u raised to the power of 3. I'm sure you know what my u is. My u is the original value. So that is x squared minus 2x. So opening it, I have it as what? 2x minus 2. And then 4 brackets x squared minus 2x raised to the power of 3, all in brackets. Now I can use my 4 to open up this particular bracket, and that'll be what? 8x minus 4 bracket what? X squared minus 2x raised to the power of 3. So I can end it here. Then what's the next thing I do? So this is my dv. I can now bring it into my formula, which is for my dy dx, for my product rule, which tells me v du dx plus u dv dx. Then what do I do? What is my v? My v is x squared minus 2x raised to the power of 4. So I have it as x squared minus 2x raised to the power of 4. And then multiply my du dx. What is my du dx? My du dx from here is what? 2x. So multiplying 2x plus u dv dx. So I have my u dv dx. U is what? X squared multiplying, let me use a different color to show everything from this side, x squared multiplying my dv dx, which is 8x minus 4 x squared minus 2x raised to the power of 3. So opening this, I have what? S squared. Now notice there's x squared here and there's s squared, so I can factorize x squared out. So I have x squared minus 2x raised to the power of 3 So what is remaining here is just 1x squared. So I can put this as what? X squared minus 2x multiplying 2x plus, here is what? Here we'll be having x squared opening 8x minus 4. Then what do I have next? Can go down, and then I have still my x squared minus 2x raised to the power of 3. So opening this with my 2x, I have it as what? 2x multiplying x squared will give us 2x raised to the power of 3 minus 2x multiplying minus 2x will give us what? 4x squared plus x squared opening this bracket, we have it as x squared multiplying 8x, we have it as 8x raised to the power of 3 minus 4x raised to the power of 2, all closed. Now we can now add up like terms, that is 2x raised to the power of 3 plus 8x raised to the power of 3. So let's bring out our equation again, x squared minus 2x raised to the power of 3 brackets. So 2x raised to the power of 3 plus 8x raised to the power of 3 will give us what? To give us 10x raised to the power of 3. And then minus 4x squared minus 4x squared will give us minus what? 8x squared. And we have this complete. So this is where we'll end it. This is actually our final answer. If you want, we can still factorize our x's out, but I don't think there will be any need for doing that. So this is the final value of our answer, and try to look at this any way we can factorize anything out again that's going to make sense to work with this. Okay, let's look at this. We have here as x squared minus 2x raised to the power of 3. Okay, so this is raised to the power of 3. Okay, no, there will be nothing to be done here. You can see factorize, but it will not make any difference again to your answer. So I can end it here, and that's it. The next video that will be coming up will be the video on the quotient rule. So we have the quotient rule. So check the next video.